13, and specifically the homework problems. Chapter 13, as you know, is already presented in your work, and it's pretty straightforward, and it talks about the process of grading. But the thing that is most difficult for most people is how to do a normal curve in the grading system, and also how to do categories. So those two things. So in particular, let's look at how to do the grading scale. And they talk about the normal curve. You use a normal curve when you're going to compare a group of students to themselves. And it's very important. Otherwise, we have a standard scale. And our standard scale is, in my class and in probably most university classes, is 90 to 100 is an A, 80 to 89 is a B, 70 to 79 is a C, so on and so forth. And that's how it works. However, there are times when they don't have a standard scale and it's not predetermined, and actually you compete against your classmates. In many situations, that's how it works. In many schools, that's how it works. So you use a normal curve for two reasons. One, when the overall grade of a test is very low, maybe it's a new test, a new format, and you're trying it out, and the performance is low. And in that particular case, let's say the mean grade on a 100-point test was 52. If you give everybody what they actually got on that, everyone's grade is going to drop dramatically. So you've heard professors say, I'm going to curve a test. And so they have to now figure out how many points do I give you, so on and so forth. But there is a process for doing this. And the grading scale for that looks like this. An A equals 1.5 S. S stands, it designates or signifies standard deviation, just like normal, and above. I always have an arrow above. So 1.5 standard deviations and above. A B is 0.5 to 1.5 standard deviations. And we dealt with descriptive statistics, so we know how to calculate a z-score and how to do a standard deviation. We know if your z-score is a 1.5 or above, then you're going to get an A. If your z-score is between a 0.5 and a 1.5, you're going to get a B. A C, and write this stuff down because we'll need it, is negative 0.5 to a positive 0.5 standard deviation. A D is negative 1.5 to a negative 0.5, and then an F is anything less than a negative 1.5 and below. Why I just put above and below, you'll see why, is because if we're not certain of our test is 100 points or it's 150, we say anything above, it doesn't matter. You can go to 100, 110, doesn't matter. It's above 1.5 standard deviations will be considered an A, and below negative 1.5. So that being said, what information do we need? Same stuff we always need. I have to have the mean, I have to have standard deviation. If I have the mean and the standard deviation, then I can figure out everything I need to know, just as we did back in chapters 3, 4, and 5 with descriptive statistics. So how do we calculate the actual grading scale? Because what you're going to have is a grade, and you're going to have to take your grade and put it into a grading scale to figure out what you got, correct? All right, so in this particular instance, the mean on the last test we took was an 82.19, and I'll round that off to 82. The standard deviation was 12, so I have that information. So that being said, if I want to create a grading scale, how do I do that? Now this isn't a great example because actually it's a good performance, and what we probably have to do is deduct grades and deduct points, not add points. So I probably wouldn't use it in this example, but the process will be the same, so you'll see how it works. So in this particular case, I'm going to say 82 and 12 is my mean and my standard deviation. To figure out how to get an A, simply take the standard deviation, multiply it by 1.5, and add it to the mean. Whatever the standard deviation is, if it's 10, if it's 15, if it's 20, if it's 12, that's what we use. So 1.5 times the standard deviation plus the mean, which in this case is 82. So I go 1.5 times 12, which is 18, plus 82 is going to be 100. So in this particular case, which is not the best example, a grade of 100 and above will be an A. Then I go through all my grades and I count how many people had a 100 or above. Now you can see this isn't going to be good because it's going to take basically away all the A's. And why? Because the class average is very high. It's an 82 on that test. Usually it would be in the 70s, but in this particular case, the class scored very well overall. So that's why it plays that way. So now I go to my B range. And my B is a 0.5 to a 1.5. You don't have to worry about the top end. You're only going to calculate the lower end. So what do? 0.5 times the standard deviation of 12, which is 6, plus the mean of 82 is 88. So I know that 88 to 99 is going to be a B. If you scored 88 to 99, there you go. I don't have the actual score, so I can't tell you how many students, but we would just go to all our scores and count up how many students or how many subjects scored between an 88 and a 99 and put that number over here where it says number of students in your homework. Then you go to a C, the same thing. Now there's a shortcut you can do. After you determine your top number, when you're doing grading scales, you can quickly determine the next category by simply subtracting the standard deviation. So 100 minus 12 is 88. 88 minus 12 is going to be 76. It's just a shortcut. We can do that when we're doing grading scales. We cannot do it when we do categories. Cannot. So 76 to 87 would be the C range. If I subtract the standard deviation again, now I'll have 64 to 75 will be the D range. And the F range is pretty simple to do because it's just anything below the 64. And since we're dealing in whole numbers, it'd be 63 and below. So now all we have to do is go and count each individual score, and we have to put them in one of these groups. And then figure out how many numbers. How many scored 100 or above, how many in 88 to 99, 76 to 87, so on and so forth. And that's how you do it. This is not a super example because you really wouldn't want to curve this. I only curve exams when it's to the student's benefit. In this case, it would be to the student's detriment. But sometimes that's the way it is. You're in certain schools, like med school, you compete against the class. When is it good to compete against the class? When the class isn't very good. Because then a lower grade, a lower score could be a better grade if the mean is not very good. But if the class performs well, it's not good to curve for the student because the student is going to lose points. Remember when we did, if you remember, when we're doing Z-scores, actually if I just give your Z-score to you on a given performance, you'll know everything you need to know. You know where you fit into a grade, you know what your percentile is, you know everything. Just by giving the Z, I don't even have to give you a raw score, just a Z-score. But I would only do that if we were comparing you to a group of individuals. In our particular class, we don't do that. We compare it to a standard score. 90 and above is an A, 80 to 89 is a B, so on and so forth. So that's the general process of how it works. But let's go and do this with the homework problem. So now let's get back to, I believe it's homework problem 13.1. I think it's 13.1. When you go to that homework problem, we're going to use the same normal curve grading scale, which is the A, B, C, D, 1.5 and above, so on and so forth. However, the first thing we have to do is run the mean and the standard deviation. And in the instructions it says run the mean and round it to the nearest whole number, correct? Should say to the nearest whole number. And the standard deviation to the nearest whole number. So that being said, when we calculate it, we'll get a mean of 69.4, which we round to 69, and a standard deviation of 12.04, which will round to 12. All right, so how do we do this? All we have to do is take the mean multiplied by 1.5 standard deviations. I'm sorry, the standard deviation multiplied by 1.5 standard deviations and add the mean, and that'll give us the top number. So we go 12 times 1.5, 18, plus 69, so we're at 87. So an A is going to be anyone scoring in 87 and above. How do we get our B? We go 0.5 times the standard deviation 12, which is 6, plus 69, which is 75. 75 to an 86 will be a B. If you look into the assignment, how many people scored an 87 or above? How many did you see? On the numbers there? So you'll see all the numbers, 87 and above, how many? Only see one?
Two.
Two?
Oh, yeah, two.
Two, okay. So we have two individuals that scored an A, that scored 87 or above. How many people between 75 and 86, if you take a look? 86, being able to look at it quickly in Excel, I can see that there were 6. And the easiest way to do it if you're working in Excel is just to sort it. So it's not discombobulated, otherwise you're trying to decipher, it gets complicated. So just sort that column in the grades, and I see we have 6. Now I would just simply go to a negative 0.5 to determine the C's. Negative 0.5 times 6 would give us a negative 6, plus 69, the mean, would give us a 63. So 63 to 74, now I can see how many of those I have. I'll look on Excel again. And I can see on Excel after sorting it that I have another 6. Now I'm going to go to negative 1.5 times 12, which is negative 18, plus 69 would be 51. 51 to 62. I'll have to see how many of those I have. I'm going to edit this right.
Yes.
They're going to be walking away coming back. Okay, from 51 to 62, there were 5 of those. And now all I have to do in the last category, I don't have to do any calculating. I can just go 1 under the lowest D, which in this case is 50 and below. I always say below. We can make a mistake of giving it a predetermined range. I'm assuming that the bottom score is a 0, but it may not be. So I just say below. Anything that's 50 and below is going to be an F. Anything that's 87 and above, it could be a 125-point test. You never know. It probably isn't, but that will be an A. So that's how it plays out. How many of those? Well, if I just count what I have here, I have 8, I have 14, I have 19. There must be 1 because I believe N was 20. So there's only one person that scored a 50 or below in this particular situation. N was 20, wasn't it? We have 20 of them? 20 of them? Okay, so that's how you would do it. Now the shortcut to doing this, as I mentioned previously, is after you set your A, the 87, and how did I get that? I took 1.5 times the standard deviation. If this standard deviation was 10, I would go 1.5 times 10. If it was 20, I'd go 1.5 times 20. In this case, it's 12, so I go 1.5. This is never going to change. This may change. 1.5 times 12, which was 18, plus the 69 gave us the 87. Once I have that, the shortcut is simply subtract in your B's 12. Just go 87 minus 12 will give us our B range. 75 minus 12 will give us our C range. Because these are equal units. You can see that it's 1.5, 0.5, negative 0.5. It's one standard deviation difference between each of the different grades. So it's pretty simple to do in this particular case. And really for homework, all you'd have to do is for your A's, you would have to put in 87 and above, or an arrow up. You would have to designate that it's 87 and anything above that are A's. And then count how many people scored an 87 or above, and there you go. That's how you solve for it. So it's pretty simple and straightforward. And that's how you do the normal curve grading style. Now in this case, that's actually pretty close to normal scale. It's a little bit off, but I would have to go in here, and if I were to give points, and sometimes you'll hear a professor say, I'm going to curve this, and I'm going to give you points. I'm going to add points to your test. In this case, they would add a minimum of 3, because they need to get that 87 up to a 90 to be considered an A. So a minimum of 3. But here it would need 5, here it would need 7, so you'd have to make a determination. What they could potentially do, they could possibly give a percent, but most professors would probably, in this case, probably give about 5 points. There's no absolute scientific way to do that. What we typically do is just make a judgment call. I know I have to give at least 3 or they're not going to get an A. I have to give at least 5 here to get them up to an 80. I have to give at least 7 here, 9 here. So the better you do, the more advantage you get on points.